I forgot to press the record button, guys. But I think this item here, we have already covered naman. So right now, we are starting recording the session. Okay, going back. So the central lemma theorem, guys, is a very good theorem that applies not only to statistics, but also to other branches of mathematics. And this is one of the things that I like. So if you notice, guys, the graph that I just draw on the screen is not considered as a normal distribution. Nga naman, what is the graph, or how should be a normal distribution graph look like? It should look like a bell shape. Remember mo atong ana na to? Right? Remember mo ana? That should be the graph of a normal distribution, approximately. Now, if you're going to take a look at the table that I just draw, this is far from being normally distributed. Agree? It's totally different to this one there, right? So it's not the same. So here's the magic. Here's the magic. Here's the magic, guys. Let's say, for example, I'm gonna pick a sample size of 4. 4 items ang ha, and I have 5 items here to choose from. So we can say, sir, so first sample na to, we can say this is random, and it's up to you kung pila ka buok. So let's just pick mga 5 or 6 ka buok. So we have a combination of 1, 1, 2, 3. Pwede? Pwede. We have S2, another sample, ng 4 ka buok. 4, 5, 2, 1. Right? We cannot add 6. We cannot add 7. Kuto ba to sa kanang numbers nga naa sa given, guys? Sunod. I did say 6 now. So S3, what else? Lagay ko combination B. Coming from you guys, lagay ko kanang 4 different elements coming from 1, 2, 3, 4, 5. Go. You may chat your answer. You may unmute yourself. Okay, good answer. Let me scroll up. I have Josh 3, 2, 4, 5. Okay, S4. I have 2, 3, 5, 4 from Simone. Guys, I'm just gonna take the first people who gave me the answer. From Janine 2553. Thank you. And then lastly, S6, we have from Ziven 2213. Okay, good. Now, each sample size, guys, we're going to compute for the mean. I'm going to grab my calculator because I don't want to do it kanang mentally. I can do it mentally, pero kung ano good guys, kanang dealing with stressful. Akong klase ba from 7:30 to 4:30 karon, and then as much as possible, I'm trying to relax my brain para dili ko ma-drain all throughout the day. Charot! So let's take the mean for this one here. 1 plus 1 plus 1 plus 2 plus 3 divided by 4, that gives us 1.75, right? 1.75. S2, 4 plus 5 plus 2 plus 1 divided by 4, that's going to be 3. No? S3, 2 plus 3 plus 4 plus 5 divided by 4, that's going to be 3.5. And if you're going to, by the way, if you're going to take a look at this illustration here, guys, it clearly shows that the mean is actually 3. The middle part is 3. So just an additional detail. Sige. This one here, S4, 2 plus 3 plus 5 plus 4, divided by 4, that's 7 over 2, which is equal to 3.5. Next, 2 plus 5 plus 3 plus 5, divided by 4, that's going to be 3.75. And then we have 2 2 plus 2 plus 1 plus 3 divided by 4, we have, so wait, 2 plus 2 plus 1 plus 3 divided by 4, we have 2. Sige. I'm going to plot these values on using a bar graph. So here, so I have numbers, smallest number nako is 2. I have 3. I have, let's say, for example, somewhere here, 3.75. I know, sorry. Dapat ay 3.5. 3.5. Then next kay 3.7. Ako na lang dako na kung kuan eh, akong labels. Sorry guys. Kana, I think that's better. Sige. This is 2 here. This is 3 here. This is 4 here. So si 3.5 somewhere here and 3.75 kay kana. And then, oh, pila gan ini? Wala ko nasuwat ni siya. 2 plus 2 plus 1 plus 3 divided by 4, it's 2. Sige. Si S1 guys is somewhere 1.75. So that's close to 2. So somewhere here is 1.75. Si S1. Si S2 is 3. S2 is 3. So somewhere here. Ano? There, S2. S3 is 3.5. 3.5. S3. And that's S3 and S4, right? S3 and S4 has the same mean. Now S5 is 3.75, so that's gonna be a little bit like that. So this is S5. And then S6 is 2, so somewhere here. Ako lang ilagyo ha para makita niyo yung difference. So this is S6. Now, if you're going to take a look at the graph, guys, the means of each sample that we pick would actually tend or would somehow approximate to being normally distributed. Look at the illustration. There. There. So the more, guys, this is just, dili kay siya intuitive tanaw sa akong illustration. However, the idea is the more you get a sample, the more you increase the sample, the more you pick a sample from the population, your sample becomes normally distributed. This is only happening, kanila ato nakita is inani ang forma because we only have 6 items or 6 samples with 4 elements. What if we extend to more samples with 4 elements? Of course, makita na yun nato unsay mahitabo sa graph. So here's a simulation nga akong ma-show ninyo guys, and which is very good example. Did I close it? Oh no, wait ha, just give me a minute. Where's my, what? Wait guys ha. Let me cancel, let me stop share ha. I think I closed, okay, here, I forgot, sorry. Clear. Let me share my screen. Here you go. This is, I'm using onlinestat.com application, guys. I hope you can see this. Now take a look at the very first graph. It's a population graph, and then it's somehow normally distributed. But if I'm going to mess this up, look at the situation, huh? Isaka na ko na dira, saka sa dira. If we're going to take a look at the situation, guys, this is not normally distributed. Agree? That's not normally distributed. The bars or the illustration doesn't give us a normal distribution graph. Kaya nga no, for it to be normally distributed, it has to be a bell shape. No? So mo na ang population distribution. Now, kaning part here, it says sample. If I'm going to pick a 5 sample lang out of this population here, mo ni ang graph. Mo na ang first 5 kani, mo ni ang graph. Mo na ang first 5 lang ha out of this. I think it's 32 kabuok items. Mo na kung 5 lang kabuok. I'll add another 5. Mo na ang forma, that's 10 out of 32. Another 5, Magsige ko add og another 5, guys. Magkadaghan akong 5. Take a look at what happened to the graph. So what can you say? If the more ta mo add og more 5 elements out of 32, what is your conclusion? Or how do you observe or how do you describe the situation now in the graph? Yes, very good. In layman's term, mapurma siya og normal curve. Di ba? How amazing ang math, guys. Oh, charot. If I'm going to pick like 10,000 items, guys, 10,000 items out of these population here, out of this population here, this is what it would look like, 10,000. See? If I'm going to pick 100,000 combinations out of 32, that's gonna be the situation now. So, mo-approximate siya og normal distribution. In other words, the idea of CLT, the idea of the central limit theorem, wrong spelling, central limit theorem tells us that the more we pick a sample from the population distribution. So the population distribution, guys, it can be normally distributed or it cannot be. It may not be a normally distributed distribution. Population distribution. So tells us that the more we pick a sample from the population distribution, the sampling distribution will approximate to become na, guys. Let me erase it. To become a normal distribution. By the way, guys, kani siya, sorry, my bad. Dadali ba ng yads? Oy, kani siya. The sampling distribution, a normal distribution. So I'll repeat. Central limit theorem tells us that the more we pick a sample from the population, in layman's term, if daghano na to og pick, sige ta og pick from the population for our sample, ang population distribution may it be normally distributed or may not be a normally distributed. Meaning to say, pwede ma-mess up, pwede katag kaayo ang population, pwede bisag unsa pa na dira, as long as it's a population. And whenever we pick the more sample size from that said population, the sampling distribution will approximate to become a normal distribution or a normal curve. And that's the beauty of statistics, guys. This central limit theorem, the formula will be used in doing hypothesis testing. So I hope, see, wala ra kay ka ng heavy computation, guys, because this is just like one mga kanang intuitive way of understanding central limit theorem, guys. I'm not gonna have a discussion or I'm not gonna have a test nga I would ask you to pick doing this. I'm not gonna ask you to do this because this would be in random and it depends on the person kung pila ilang gustong kuhaon, just to illustrate the normal distribution from being not normally distributed. Gikan ani being like this. And if you're going to take a look at here, the S4 and S3, guys, the mean would be approximately close to 3, 3.5. Ang population mean is 3. Magkadaghan pa yun na, guys, magka-close pa yun na og 3 ang mean. So yeah, same atong ganiha, na equal ang mean sa population o ang mean sa mga sample sizes. Questions so far? No questions? That's right. Huh? Ay, okay. Ang inyong nakita kay ang sampling distribution ra, katong simulation. Okay. Ang kuan guys, ako nang gidiscuss ang summary actually kanina. Sorry, kani. Central limit theorem tells us that the more we pick a sample from a population distribution, that population distribution may be normally distributed or may not, then the sampling distribution will approximate to become a normal distribution. So that's the whole idea, guys. Kani siyang illustration nga akong gi-show kani here. What I'm trying to say earlier is that I'm not going to ask you to do this because this is going to be subjective. This is going to depend on the person who wants to really understand how to illustrate a normal distribution from a population that is not normally distributed. So dili ta mo pabuhatog ani. What I'm going to ask from you though is that compute the mean, compute the variance, compute the standard deviation, the expected value, and so on and so forth. And your understanding on what's going on with the central limit theorem. So inaana ra siya. Question so far? None so far? OMG, wait. Wait guys ha. Na nag-message sa messenger. Okay, question so far? For this item here. No questions? Okay na? Sige, I'm gonna stop sharing, okay? I'm gonna share my PowerPoint presentation for hypothesis testing. Sige, I hope, I forgot to, I'm sorry guys, but I forgot to edit the animation of this presentation. I wish to like minimize the animation kaya ano, if mag PowerPoint presentation man good and then animated, mulag siya. I mean, not technically dugay pero naalay delay. But yeah, I hope this works for you. Okay. All right, so we're gonna talk about, how to hide there. Okay, so inferential statistics, this is the second part of our course for statistics and probability. This is where we do hypothesis testing. I also was not able to update the reference, guys. The book that you are using should be part of this references here, okay? So just bear with it. So we're gonna talk about hypothesis testing, and this is a file that I created for Cebu Doctors University Senior High School Department. O, di ba? Sige. Let's have a scenario. A principal read a news says that the overall mean score for the achievement test is 910, okay? So if you were to be like the principal, guys, it matters to you what is the overall test score or mean score for all the schools who took the achievement test. Kaya nga naman, humot man na sila ha as a school if taas og percentage or taas og average. Now, he was able to verify that the achievement test mean score of his school is 960, which is greater than the achievement mean score of 910. Now, the question here then is, would you agree with the principal that he bested all other school? I need your answers. Anyone can unmute their microphone, or maybe you can type your answer on our chat box, but I need your answer. I need your opinion. I'm gonna swing. I'll just wait here, huh? I'm gonna wait for your answers. So I'll repeat the situation, huh? The principal read a news on the newspaper that the overall mean score for the achievement test is 910. That's overall. Now, he was able to confirm that the achievement test mean score of his school is 960. Now, would you agree with him that his school bested all other schools? Okay, Mel said no. Um, I don't know. Rigel, Sanerpida said, I guess not all schools, sir. Um, okay, I assume you answered no. Simone answered no because there might be other schools with even higher average. Okay, good point. How about your reason, Mel? Why do you say so? Nga it's a no. As per Mel, he said, since the score is the set standard for the achievement test, sir. Okay, very good. Meaning to say there is a standard score for it to be considered as high or low. Next, maybe bested most school, but not all, not all, okay? It's not clear stay whether low sad or scores ang ubang school. Very good. So guys, I'm so happy that you open your mind with these type of questions. The same thing with your grade, guys. If someone is higher than you, I mean having an average of higher than you compared to your average, that doesn't mean that that person is better than you. Okay? We didn't consider the score of each school. We only consider the mean average or the mean score. Remember that aside from studying the mean, we also need to consider the variances or the standard deviation, the distance from each score to the mean score, because these distances matter, right? And also, good point, it's not clearly stated, according to Mel, guys, it's not clearly stated though whether low scores ang ubang school. Very good. That's one point that we can consider. Good job, guys. So the answer is going to be no. No, Mr. Principal. We wouldn't agree with you because we cannot exactly say your school bested other school because we don't see the score of other schools in the first place. We are only seeing the average mean score of all the school who took the achievement test. It could be that your mean score is 960. However, it could be that there are another school who got higher than that. Clear? Very good. Naka-bright ani nila oy. So I think ready na ta for a quiz, no? For a quiz on Friday. Sir, why Classy Friday? Just kidding. Wala pa ko'y plano mag-quiz for this week, guys. Just an assignment lang. Pero dili siya commutation nga assignment. It's like interpolation pa on your opinion and whatnot. Sige. I hope there's no question in this part here. All right. So these are the following questions, guys, where inferential statistics is very useful. Okay, these are the very, not very, but most of the questions asked when you do inferential statistics. Inferential statistics comes with research, okay? So when you do researches, inferential statistics would actually kick in, especially if you're doing quantitative data analysis. Is inferential would help you out to do that. So here's the first question. Is the Earth warming? What do you think? Subjectively, we can say yes because that's how we feel right now. However, if someone would ask you for evidence if it's really warming up or warming down, it's going to become like a research study na. You have to look for supporting documents, you have to look for supporting literature and related studies to really convince people that Earth is really warming up. Aside from the related studies, you need to consider data analysis that you cover or you gathered, and how to gather data analysis, that's going to be discussed during your quantitative research too. I think quantitative research, it's going to be discussed on that, I think, second semester or first semester of grade 12. Next question. Will this new medicine lower person's blood pressure? Good question, right? We cannot immediately say yes or no unless there's an evidence being provided. The same thing goes to vaccine for the COVID-19. Before we can question if the vaccine is really effective or not, it goes a lot of phase trials, right? I think, if I'm not mistaken, phase 4 before it would like be distributed full blown for all the people in the world. It has to undergo 4 different trials. And these trials are very important because the data gathered from these trials, guys, will be used for data analysis and inferencing. Okay? So yeah, that's one thing that we can actually consider doing inferential statistics. Next question is going to be, is the new teaching style better than the traditional one? A good example for this one, guys, comparing teaching style, is the face-to-face teaching and the online teaching. Now, people might say that, yeah, the online teaching may be effective or more effective than the face-to-face, or some people would say, I like face-to-face better than online. But that's going to be subjective in the sense that people's perception was expressed, not technically providing a concrete evidence that show that the new teaching style is better than the traditional one. So it has to be done. It has to be researched. So there should be an inferential statistics, or there should be quantitative data analysis to provide a concrete evidence that the new teaching style is better than the traditional one. Next, number 4. Would you, or will, it's not, okay, sorry. Would seat belts will reduce the severity of injuries caused by accidents? What do you think so? It's still going to depend on the data gathered, guys, from those people who are fastening their seat belts and those people who are not. Because data would actually tell us a lot of things. And one thing that you need to also consider is that you know how to interpret data. You know how to understand mean, median, mode. You know how to understand the standard deviation of the variances. Now, these 4 questions are just like 0.00001% lang out of all the questions that you can find in scientific world. Okay? Because when you do scientific studies, guys, it's going to be quantitative research most of the times. And scientists or doctors or scientists, doctors, physicists, they rely more on experimental research, because experimental research would give them like a concrete or a grounded data to interpret. For example, when it comes to like creating meds or something to apply to human body, they are going to use rats, right? Monkeys, and any species that are close to humans' features. Mga inana, guys. And of course, mawagi na sila og mga approval, what else? Mga permission for like doing the research, because, you know, naanay mga ethical situation na dapat i-consider. Okay, questions so far for this item here? None. Okay, so let's proceed to the next slide. Okay, so these are the 3 methods of using or of doing test hypothesis or testing hypothesis. We have the first one, the traditional method, the p-value method, and the confidence interval method. I am going to focus on the first 2 methods. I'm going to discuss it to you guys. However, for the third method, guys, it's going to be on a higher level now, so it's going to be discussed in college. But these 3 methods would give us the same answer. So if you're to be the researcher, it's up to you to use either of the 3. It doesn't have to be like, it doesn't have to be forced na dapat first method inyong gamiton, dapat second method inyong gamiton, dapat third method yung gamitin. Either of the three would give us the same realizations and interpretation of data. Let's define first what is hypothesis test. So a definition of hypothesis testing, guys, it's a decision-making process for evaluating claims about a population. So when we say decision-making process, it's a process, meaning to say it goes with first step, second step, third step, and so on and so forth. Meaning to say you cannot make a decision right there and then. It has to undergo different steps or processes. And when we say evaluating claims about a population, it's an example like this. If I'm going to say that most of the people in block E, 11 block E, are intelligent, that's going to be a claim. So for it to be proven, or for it to be proved, I need to pick a sample size from block E and test them if it would really give us an idea that most of the people in block E are intelligent. So katong sample sizes will be used for me to be able to gather data, and from the data, I would make interpretation to approve the claim, to agree with the claim that most of the people in block E are intelligent. And that's how we do research, okay? We pick a sample from the population. And the more sample we get from the population, the more sample becomes a normally distributed sampling distribution. CLT, central limit theorem. Diba? So here we have two statements of hypotheses. The first statement of hypothesis, guys, is we call the null hypothesis, okay? The null hypothesis states that there's no difference between a parameter and a specific value. When we say parameter, guys, these are values coming from the population. Do you remember the notation for the population mean? This is the population mean. This is the variance. Sorry, wrong. It's incorrect. That's the variance for the population. And this is the standard deviation of the sample. While these notation here, guys, this is the mean for the sample. This is the variance for the sample. And this is the standard deviation for the sample. So I hope you know the difference of these symbols, okay? Let me clear and delete all drawings I did, okay? So here, again, when we say the null hypothesis, we can say that there is no difference between the population parameter and the sample statistic. We call them statistic without S. That's the null hypothesis. And that's how you state it. Let's work on alternative hypothesis. Alternative hypothesis would tell us that there is a difference between the two values, okay? The parameter and the sample statistic. Now, when we say difference, guys, there are three different items when we talk about differences. First, it could be not equal to. Okay, when you say different, lahi ba ya? Second, less than. Okay, difference man kaha. Third, it could be greater than. Okay, difference man. So guys, if you're going to ask me, sir, when to know nga mugamit ko og not equal to, less than, or greater than. We are going to cover that on the next slide. It's still 2:36 na kuyawan ko daabi na ko kuan na. Kanang abi na og 3 na. Sige. So here, oops, kita na mo sa answer. Sige. Here. Sige guys, I'm gonna give you like maybe 1 minute to focus yourself on the statement of null hypothesis and the alternative hypothesis. Try to familiarize and focus yourself sa mga naka-bold nga fonts. I mean, naka-bold nga letter or words. I'll give you 1 minute. Okay, so I hope you have an idea now how the difference between the two statements. Sige, let me proceed to the next slide. This example that we have, guys, is going to be a practice on how to state the null hypothesis and the alternative hypothesis. Let me read the problem first. If you want, you can also read it silently. I mean, nakamute na mo, so you can read it aloud sa inyong end. A medical researcher is interested in finding out whether a new medication will have any undesirable side effects. The researcher is particularly concerned with the pulse rate of the patients who take the medication. Will the pulse rate increase, decrease, or remain unchanged after a patient takes the medication? Since the researcher knows that the mean pulse rate for the population under study is 82 beats per minute, the hypotheses for this situation are. So what do you think is going to be the null hypothesis? Do you remember what did we mean by null hypothesis earlier? How do we state it? It says that there is no difference between the parameter and a specific value. So if we're going to have this example here, what do you think is the null hypothesis? 1 minute, you can place yourself on mute, or you can type your answers. I wanna swing from the chandelier. Party girls don't get hurt anything when I push it. Ringing my doorbell, I feel the love, I feel the love. Remain unchanged, okay? So that's a good answer, very good. Remain unchanged or equal. Agree, Krisa? Equal. So let's have there. So the null hypothesis says there is no difference between the parameter and the specific value. The parameter, guys, is the mean from the population. The specific value is the 82 beats per minute. It says here, a researcher knows that the mean, when you say mean or average, pulse rate for the population under study is 82 beats per minute. And since we talked about earlier that null hypothesis should state that there is no difference between the parameter and the specific value, then the answer should be like this. Mu or average or population mean equals 82. What do you think is the alternative hypothesis? Okay, either increase or decrease. Remember earlier I said that there are 3 different symbols that you can use, either not equal to, less than, or greater than. And I said on the following slides, you would know when to use these 3 symbols. So with that being said, which symbol do we need to use for this, for our alternative hypothesis? What do you think? Is it not less than 2? I mean, greater than, less than, or not equal to? Good. Good job, Zeven. It's not equal to. Why it is not equal to? The clue, guys, is here. Will the pulse rate increase, decrease, or remain unchanged? Your answer, Rona, is actually correct in terms of sentence construction. It's correct. That's totally fine. The pulse rate will either increase or decrease. And to combine increase or decrease in a sense of doing a symbol, it's not equal to. Tama? Mean to say na difference. That's how we state the null hypothesis and the alternative hypothesis with the help of mathematical symbol. Mu equals 82 and mu not equal to 82. Now, if you want to write them in a sentence form, that's totally fine. And here is the scenario on how to do it using a sentence form. The alternative or the null hypothesis, you can say there is no difference between the means because we're comparing, Manggod, the mean of the population and the mean of the sample size. So the null hypothesis states that there's no difference. So you can say there's no difference between the means. Kaning means nga pasabot ani guys are the means coming from the population and the sample size. Okay. Alternative hypothesis, you said nga there's now a difference. So there is a difference between the means. The means again will be population mean and the sample mean. Question so far. So which do you think is better way of answering the or stating the null hypothesis? Using symbols or using sentences? What do you think? There are guys. We have different preferences. That's what make us individual. Either of the two guys, I'm gonna consider it. Anyway, I'm gonna check your work, man. Okay, so it's up to you if you want to use. But remember, your sentences should make sense. Okay, it should jive with a given problem. Okay, so let's have another example. Here, a chemist invents an additive to increase the life of an automobile battery. If the mean lifetime of the automobile battery without additive is 36 months, then her hypotheses are. So what is the null hypothesis? I'm gonna swing. Equals to 36? Okay. Is that a question, Krisa, or answer? I haha answer. All right, so guys, anyone who would like disagree with Krisa? Any violent reaction for Krisa, guys? Krisa, your answer is wrong. Who would say that? Or everyone agrees to her? Agrees with her, sorry. Okay, the answer is the mean is equal to 36. There. Perfect. Now let's work on the alternative hypothesis. What do you think is the alternative hypothesis? Ang mo disagree po sila. Ka-harsh, oy. So how about the alternative hypothesis, guys? Not equal to 36, Rona? Okay, good. Good point. Guys, the idea of doing hypothesis testing, I want to point this out to all of you because this is very important. You have to level your understanding with, you have to make your understanding level a little bit higher on the situation of the problem. So you have to understand, you have to level up your comprehension in the problem. So saying not equal to 36, Rona, good try, but there's a better way to answer it. Using the words in the problem. You're using your understanding in the problem. So when we, very good. That's what I'm talking about. There. Greater than, good job. Maybe later na mo na-realize, Rona, no, it should be greater than will increase. Not equal to, because, nagets na, Rona? Nagets na, Rona, what I mean to say earlier. Okay, very good. So your alternative hypothesis is average or the population mean should be greater than 36. Where do we get that 36? It is because of this statement, an additive to increase the life of an automobile. So again, we need to, again, go back to our basics on how to understand problems in English, okay? So Or for those people who would prefer sentences, we can do this. There's another example. There's no difference between the means and the alternative hypothesis. You may say the mean is greater than 36. Either of these two guys, I'm good. I'm totally okay with the symbols. I'm also totally okay with the sentences. But ako lang just sa sentences, guys, is you need to make sure your sentences jive with the problem. And say, go with agree with the problem. It makes sense with the problem. Okay? So another example. A contractor wishes to lower heating bills by using a special type of insulation in houses. If the average of the monthly heating bills is 3,978, his hypotheses about the heating cost with the use of the insulation are. So what's our null hypothesis? Very good. Equal to 3,978. Good job, Simone, Krisa, and Josh. There. And what do you think is the alternative hypothesis? Mean is lesser than perfect. So, ma-perfect na tayo ni quiz, ani guys. Maka-proud, in fairness. Good job, everyone. Kudos. So it's less than 3,978 because it's lowering down or lowering heating bills. That's the root word or sentence or phrase. You can also do this. Guys, there's a typo error with the numbers here. That should be 3,978, okay? So you can say the alternative, no, you can say the null hypothesis as there is no difference between the means. You can also say the alternative hypothesis as the mean is less than 3,978. It's a typo. Question so far, stating the hypothesis. Guys, we're done with the first step. Remember I said earlier in doing hypothesis testing, it's a decision-making process that evaluate a claim from the population. So when you say decision-making process, it has step 1, step 2, step 3, and step 4, and so on and so forth. So we're done with step 1, how to state the null hypothesis. An alternative hypothesis. And here is the concept of doing less than, greater than, or not equal to. We are still going to be using the normal curve, guys, the standard curve here. We use two-tailed test when our alternative hypothesis uses not equal to. And that's two-tailed test because we are dealing with two different critical regions, the right and left regions. We use right-tailed test if we're going to use greater than for our alternative hypothesis, and we only consider the critical region on the right. We use the left-tailed test if our alternative hypothesis uses less than symbol, and we only consider the area as the critical region on the left. So just do not memorize, so just be familiar with this. That's actually, I think, step 2. Yeah, step 2. These are the common phrases that you can consider when to use less than, greater than, or not equal to. So I'm gonna give you like maybe 2 minutes, or not, 2 minutes is very long. 1 minute to take a screenshot and then read it and then somehow familiarize with with the terms, common phrases. That would actually give you a clue if you're going to use less than, greater than, or not equal to. 1 minute starts from now. Look, it's already 2:52. Dali sa oras, guys. All right, so let's proceed. Okay. Statistical test. This is the data obtained from the sample to make decision about whether the null hypothesis should be rejected or not. So the idea here, guys, is whenever we solve the statistical test, it's the third step, statistical test, that's going to be the basis for our decision making if we have to reject or accept the null hypothesis. The basis for the decision making is the null hypothesis. If we reject the null hypothesis, meaning to say the alternative hypothesis is true. If we accept the null hypothesis, meaning to say the alternative hypothesis is false. Okay? And talking about false and true, we're going to deal with two different errors, type errors. I'm going to go directly to the last item or to the last slide for that particular error. Okay, here's the scenario, guys. The null hypothesis is true. However, you reject it, reject the null hypothesis. That's type 1 error. The type 2 error is that the null hypothesis is false, but you accept it. When you say fail to reject null hypothesis, it means to say you accept it. So when you accept a false statement, that's type 2 error. When you reject a true statement, that's type 1 error. One concrete example, guys, is here. Like, ano ka na ganing kuan ka ng pang-end ni siya nga discussion. It's already 2:54. Naka-try mo magkuano ka ng watch mga movies. Like, in a court, gani ka ng mag-trial in a court. Di ba naman ay suspects and victims or accused or whatever. Let's say, for example, the accused really did the murder. No? Iya, siya siya gabot sa murder pa. Ato lang i-assume na siya gabot sa murder. However, the jury decides to drop the case. The reason is, dili strong ang evidence against the murder. That's going to be what type of error? That's going to be type 1 error. Because we reject the idea that that person is the murderer. We did not accept that he is the murderer. We reject nga, dili siya murder, even though true nga murder siya. That's type 1 error. Type 2 error, guys, is, let's say, for example, same yapon, sa court yapon ha, court nga scenario. This is injustice still. And you know, injustice is very wrong. And I'm not going to like discuss more about politics because I hate politics. It's like tag-out, so matagang go, sir, everything is political. No, I don't want to talk about politics. So type 2 error, guys, is like this. Accused yapon, murderer. Dili siya ang murder. Dili siyang murder ha. However, because of the evidence provided, because of the strong evidence provided, accusing him being the murderer, even though he is not, he is still tagged or he is still convicted to be the murderer. So we fail to reject nga dili siya murderer rather. We fail to reject nga dili siya murderer. Instead, we accuse him being the murderer even though dili siya ang murderer. That's type 2 error. Okay? So I hope you understand the difference between type 1 error and type 2 error. So far, guys, if we're going to imagine what would be the assignment for this week, it's not technically a heavy computation, but it's just like kuan lang, guys, kanang mga concept-wise, what else? Just read your book. It's in the book. Everything is in the book, guys. All of these are in the book. Questions so far. It's already 2:56. I think we should leave the 4 minutes for question and answer. Let's check, imitate, no? Anyway, so questions. Questions, guys? If there's none, I think we should, or we can end this session. And this is again recorded. The recording will be uploaded within the day lang, guys, hakay. It takes time for Zoom to convert the video to MP4. And then it takes another time for me to upload it in Shallow. And Shallow right now is very slow. I'm not sure. You guys are having issues with Shallow and Bongo? cello din cello, 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 cello. Ts, ts, cello, 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 cello. Una, dos. No more questions? If there's none, then let's end this session, guys. Thank you so much for staying up with me. We're going to meet next week because we're going to meet once a week lang. The assignment deadline will be 11:59 p.m. on Saturday because there's no class on Friday. Yay, another no class. 3 days rest. Thank you so much, and you guys take care. Goodbye, everyone.
Goodbye and thank you, sir.
Bye.
Goodbye and thank you,
Goodbye
sir.
and thank you, sir.
Thank you and goodbye,
Goodbye and
sir.
thank you, sir.
Asa ang end meeting? Stop share and then end.